Okay, listen. Today we're going to talk about adding and subtracting rational expressions. Rational, just a grown-up way to say what? Fraction. Okay, yesterday we multiplied and divided. What's the thing we have to remember? What's the difference when we start our process and everything when we're multiplying and dividing? What's the big thing we got to do, Luke? Yesterday, multiply, divide. Do we multiply and divide exactly the same way? Tell me, what do we have to do first? Keep, change, flip when we divide. We do not need a common denominator multiplying and dividing. I know you were thinking about today. That's fine. What did we have to do to each piece of our fraction before we could multiply or divide? We got to simplify. We have to factor, okay? Factoring is never going away. So again, guys, if you're not fluid and fluent with it, come to me. There's all sorts of extra factoring practice, but we've got to get to where it's like second nature to just run through things, okay? If we're spending a lot of time trying to figure out how to factor within the problem, you're going to run out of time on a test or a quiz. So we just need to build our fluency with that. So chapter P, section 5, part C.com is adding and subtracting rational expressions. Let's remind ourselves how we add and subtract. Let's go back to elementary school. You have to have the same denominator, right? Got to get a common denominator. You have to make sure everything is factored first, so we get our least common denominator. We'll figure that out. You multiply each term by what's missing, add and subtract the numerators. We have to remember when we're subtracting, because we're going to subtract polynomials, we have to distribute a negative sign. So let's start off simple here. Some of you like to write horizontally, some of you like to write vertically. It does not matter to me. But if I was to add 1/2 and 1/3, okay, I'm going to write it vertically because I like to. So 1/2 plus 1/3. What is a common denominator between 2 and 3? 6. How did you arrive at that answer? You multiplied, okay? So I'm going to go ahead and say, fine, my common denominator here is 6. And then I'm going to ask myself the question, how did I get from 2 to 6? Mathematically, what did I do to get from 2 to 6? Multiply by 3. You got to be fair with fractions. What you do to the denominator, you do to the numerator. What you do to the top, you do to the bottom. So 2 times 3 is 6. So in my numerator, 1 times 3 is, oh Lord, whew, okay. I know this is very basic. I get it. We'll get there. Hold on. So look at 1/3. How did I get from 3 to 6? Times 2. So what you do to the bottom, you do to the top. 1 times 2 is 2. And then we add numerators. Your denominator stays the same. 3 plus 2 is 5. So you have 5/6. Again, I get that's very basic. We'll work up to some things here in a second. Do you notice, guys, how 2 and 3 are completely different numbers? Right? Don't have anything in common? Okay, so let's look at number 2. I have 1/6 plus 1/12. What's the relationship between 6 and 12? Okay, divisible by 2. Fair. What else? What else is the relationship between 6 and 12? 6 times 2 is 12, right? So in this case, you're not just multiplying 6 and 12 together. You could, boys, and get, Anthony, you could and get 72 and then make equivalent fractions and add them, but then you'd have a lot of simplifying to do. So what's the least common denominator? What would the least common denominator be between 6 and 12? 12, I agree. So you don't have to do anything to your 1/12. That just stays 1/12. And then what do I multiply 6 by to get to 12? 2. So what we do to the bottom, we do to the top. So I have now a common denominator. You add your numerators. 2 plus 1 is 3. Do we leave our fraction like that? No. What does that reduce to? 1/4. Okay, good. All right, now we're going to do the exact same thing, guys. That same process, but now we have expressions. We have variables. What do we need to remember when we're doing this? First of all, x plus 1. Put it in a parenthesis. X and positive 1 are stuck together. You cannot separate them. You cannot just cancel numerator, denominator if they have, like the ones or something like that. Because x plus 1 is stuck together. So I'm going to, same exact process. I look at my denominator. Is the denominator the same? Yes. So I'm going to rewrite my denominator one time. God bless you. And then I'm going to say 1 plus 2. Just add the numerators. So what's 1 plus 2? So I end up with 3 over x plus 1. Is there anything I can do to simplify that? No. We're good. Does anybody have any questions? Okay. Next one's a tad bit different. Notice, first of all, is there anything to factor in a denominator? No. Are my denominators the same? Yes or no? Perfect. So I'm going to rewrite my denominator one time. And then I'm going to combine the numerator. So watch, guys. X plus 1 minus 2x minus 3. Why did I make a big deal to say x plus 1 minus and then 2x minus 3? Please tell.
Wait, I have a question.
Uh-huh.
What happened to the denominator?
What do you mean what happened to it?
Like, it's x plus 2, wouldn't it be squared?
No. No, when you have a common denominator, the denominator stays the same. You just rewrite it. You don't multiply it or square it or anything like that. You just write it one time. But what do I have to do with that negative sign, guys? I have to distribute. Some of you are going to want to do all of this in one step. Do it in your head. You're going to miss a sign. I'm telling you that now. It is a super huge deal when you just, quote unquote, miss a sign. You're going to get points off for things like that. So please be careful. Take your time and be meticulous. So I'm going to rewrite my denominator one more time, x plus 2. My numerator is x plus 1. Then what? Minus 2x, good. Plus 3. Very good. You've got to distribute that negative. Now can we combine like terms? Yes. So I have a positive x and a negative 2 is negative x, good. And then 1 plus 3 is plus 4 over x plus 2. Remind yourself, negative x plus 4 is stuck together. Guys, can I just cancel out the x's? Yes or no? No, some of you are going to do that. And I'm going to scream as I'm grading your test or quiz because you cannot do that. That is bad math. That's not simplifying. Negative x plus 4 is one quantity together, and x plus 2 is one quantity together. You cannot just randomly cross off when anything is attached with a plus or minus sign. Yeah.
Do you still have to take out the negative?
No, you can leave it like that. Right? Or do they need to say negative x plus? Okay. Yes, sir. Absolutely, Vito. All right, scooting along. All right, now we're going to have to think just a little bit. All right, let's go back to 6 and 12. We did that first one. You guys are like, oh, this is so easy. All right, we're going to try to find a common denominator. You can just multiply together, but it makes your simplification a little harder. You want to find the least common denominator. What would my least common denominator be between x and 6x? 6x, I agree. So this is how I like to look at it, guys. You can do whatever you want if you've been taught a different way, but I like to look at it and I say, okay, here's my denominator, and I look at each fraction independently. My first fraction has the x. In order for the denominators to be the same, what is it missing? The 6. So if I multiply the bottom by 6, what do I have to do? Multiply the top. Good. So I have, now these denominators look the same, right? Look at your second fraction. It already has a 6x, so do I need to multiply by anything? No. So 1 times 6 is 6 plus 5. When I simplify this, what's 6 plus 5? 11, good, over 6x. Can I simplify? No. If it was 12 over 6x, could I? Yeah. But it's not, so we can't. Okay, again, pay attention here, guys. This is an x by itself. And this is an x plus 1. It's not that one of the fractions is missing a quote-unquote plus 1. Those are two totally different things. So when our two denominators were 2 and 3, how did we arrive at 6? What did we do with 2 and 3? We multiplied. So if I have x and x plus 1, what can I do to get my common denominator? Nope, can't just add a 1. Those are two totally different things. So I can multiply them. I can say x times x plus 1. And then look at each fraction independently. My first fraction has the x. What is it missing so the denominator looks the same as the one in blue? X plus 1. So I'm going to multiply the bottom by x plus 1. If I multiply the bottom by x plus 1, what do I do to the top? X plus 1. Good. So then I look at my second fraction. My second fraction has the x plus 1. What's it missing? The x. If I multiply the bottom by x, then I do what? The top by x. So I'm going to rewrite everything I have. I have 1 times x plus 1 times x. Leave your denominator. We've gotten our common denominator. You leave it. Don't start canceling things out or anything. 1 times x is just x, right? 1 times 1 is 1. Plus 1 times x is x. God bless you. Did you see?
Yeah.
Okay. Bless you. Okay, so combine like terms. What's x plus x? 2x plus 1. And my denominator is x times x plus 1. Is there anything that is exactly the same on top and bottom that we can cancel out? Exactly the same, like yesterday. No. My 2x is attached to that plus 1. In the denominator, I have an x plus 1 that is attached. Yes, sir. You want to multiply it out to x squared plus x? I mean, you could. I'd rather you leave it in its factored form since it's asking us to simplify, but it's technically Alec, that would be fine. X squared plus x. All right, let's look at number 7. Again, we have 2 completely different denominators. Nothing needs to be factored out. So when I have 2 completely different, what? Yes, sir. Sure. What do I do to get a common denominator with my 2 completely different denominators? Multiply them. So I'm going to write x plus 2 times x minus 4. And again, we're going to look at each fraction independently. My first fraction has the x plus 2. What is it missing? Dylan, what's it missing? So if I multiply the bottom by x minus 4, what do I do to the top, Dylan? No, if I multiply the bottom by x minus 4, what do I do to the top? Okay, I need you to pay attention while I'm talking, please. Thanks.
What was the answer to the last one?
So now my second fraction, I have the x minus 4. What is it missing? So my denominator is the same. X plus 2, perfect. What you multiply to the bottom, you do where? To the top. You notice, guys, I keep saying the same thing every time. The process stays the same. Don't invent new math when you do this. So now let's rewrite our numerator. I have 1 times x minus 4 minus 3 times x plus 2. My denominator is staying the same, right? X plus 2 times x minus 4. So when I distribute, 1 times x is x. 1 times negative 4 is negative 4. Negative 3 times x, guys. Negative 3 times x. Negative 3x, okay. And then what happens with negative 3 times 2? Negative 6, okay. Combine like terms. X minus 3x is negative 2x. Negative 4, negative 6. Negative 10. And your denominator stays the same. You guys see anything we could simplify a little bit? Can I take out a 2? What kind of a 2? Let's take out a negative 2. Go ahead. So I'm left with x plus 5, and on the bottom, x plus 2, x minus 4. Is there anything that is exactly the same in the numerator and the denominator that we can go ahead and say, oh, we can cancel that out? No? Yes? No? Okay. All right, good to go. I think either way would be fine. Let me check with Ms. Corey and Ms. Fernandez on fully simplifying how we're going to do it. I'll let you know before the test. But just understand, if you can simplify, go ahead and try and simplify. Is that what you're going to ask, Valerie? Okay. Okay, again, are these two, is this the next one? Yeah. Are these two completely different? Yes. I don't have to factor anything, so I'm just going to put them in a parenthesis so I remember, okay, x is with negative 3. 3x is with the 4. So if I have 2 completely different things in my denominator, how do I get the common one? You multiply. You just stick them together. It's actually much easier when the denominators are completely different. Because you don't even really have to think. You just take each of them and just stick them in the bottom. And then you figure out, okay, this first fraction has the x minus 3. hold on, technical difficulties. We have the x minus 3. What are we missing? 3x plus 4. My second fraction has the 3x plus 4. What's it missing? X minus 3. So again, some of you are going to want to do all your math up there. I don't think that's the greatest idea, just so we don't miss a sign. I'd like to be as organized as possible. So I have x times 3x plus 4 minus 2 times x minus 3. And again, once we get that common denominator, you just keep rewriting the denominator. As I say how organized I am, and I'm starting to get messy. Let's distribute. What's x times 3x? 3x squared. Good. What's x times 4? Perfect. What's negative 2 times x? Negative 2x. Good. And what's a negative 2 and a negative 3, guys? Plus 6. That's where we're going to have issues. You guys are going to miss a sign because you're trying to do everything up here in the numerator, and you're going to say, oh, 2 times negative 3 is negative 6. When we do that, then the whole problem is going to be wrong. So we don't want to make silly mistakes. What can I combine in my numerator? 4x and 2x? What is this going to become? Positive 2x. Good. So I'm left with 3x squared plus 2x plus 6 over x minus 3 and 3x plus 4. Always check to see if we can factor. There's not a GCF. And then factors of this would be 18. Are there factors of 18 that multiply to give me 18 and add to give me 2? So there you go. This is why factoring and combining like terms, all that stuff is so important, because you can't really go back and check these. It's not like when we factored, you could foil it back together and see what you got. It doesn't work that well. Yep. It's a very good question. Somebody asked that last period. They're like, wait a second, look, there's a 3x plus 4 here and 1 here, which I agree. We had to get them. We're trying to get them to be equivalent. I cannot cross anything out on the top and bottom until I'm done combining all the like terms in the numerator because of that minus sign. If that was not there, Alec, if that was just like multiplying, then yes, you absolutely could. But since that's a minus sign, that's saying, okay, all of this stuff is attached, so I got to clean it all up, combine like terms, and then figure out if I can simplify more. Sure. All right, 3 more. Look at number 9. Again, these are completely different, correct? So what's my common denominator when I have 2 completely different denominators? 2x minus 1 and x plus 2. Just stick them together. So my first fraction is missing what? It has the 2x minus 1. What's it missing? Perfect. If I multiply the bottom by x plus 2, then I multiply the top by x plus 2. My second one has the x plus 2. What's it missing? 2x minus 1. So we're going to multiply the top by 2x minus 1. I'm going to rewrite what I have. So x times x plus 2 minus 1 times 2x minus 1. My denominator stays the same. If you guys want to just simplify the numerator and wait till the end to put it over the denominator, that's fine. You don't have to keep rewriting it. But let's go ahead and distribute. What's x times x? X squared. What's x times 2? 2x. Good. What's negative 1 times 2x? Negative 2x. And negative 1 times negative 1 is plus 1. So what do you guys notice happens with the 2 x's? They cancel. Good. So you're left with x squared plus 1 over 2x minus 1, x plus 2. Can you factor x squared plus 1? No. Can you factor x squared minus 1? Yes, but not plus 1. All right, so we come to 10. 10's a tad bit different. These are not common denominators. They are different from each other. But what do you notice you can do with x squared minus 9? You can factor this. I'm going to break this down into x plus 3 and x minus 3. You always want to factor first. So I need to find a common denominator that's a combination of the both. This is very similar to like the x and the 6x or the 6 and the 12. They kind of have some things in common. So what would be a common denominator between these two? The least common denominator. They both have an x plus 3, right? Good. And then what's the other piece? The x minus 3. You write down what they have in common and then what's different. So I look at my first fraction. It has the x plus 3 and the x minus 3. So do I have to do anything? Do I have to multiply this numerator by anything so the denominators here look the same? No, they already look the same, so I have a 2. So I have plus. The second fraction has the x plus 3. What's it missing? What you do to the bottom, you do where? To the top. Perfect. So I have 4 times x minus 3 in the numerator.
Why'd you say that we're not doing it to the top of it?
Because this first fraction, that first fraction, if you look at the original numerator, it's x plus 3, x minus 3. And then when we figured out what our common denominator is, x plus 3, x minus 3, it's the exact same. So you don't have to multiply the denominator from the original to our common one by anything because it already is the same. So now I'm going to take my 4 and I'm going to distribute. So I have 2 plus 4x minus 12. You guys agree? Over x plus 3x minus 3. What can I combine here? 2 and negative 12. Okay, so I have 4x, what? Minus 10 over x plus 3, x minus 3. How could we simplify that a little bit? Take out a 2. So I have 2 times x minus, 2x minus 5, sorry. 2x minus 5 over x plus 3, x minus 3. Same thing. Again, I'm not sure. I'll ask Ms. Fernandez and Ms. Corey how we're going to score the simplifying and stuff like that. I would imagine 4x minus 10 is fine. If you go ahead and simplify more, that's fine as well. But please leave everything factored. Don't FOIL it back together. All right, we're going to do this last one, and then I have actually an extra one I want to do just to make sure if you see it on WebAssign. But how's this one a tad bit different? There's 3. Does it make the process any different? No. Doesn't even really make it much harder. Look to see if you can factor. Can we factor anything?
Oh, wait.
X squared minus 1, right? It's going to give me x plus 1, x minus 1. So what is a common denominator going to be between x plus 1, x minus 1? I'm just going to take what they have in common and then what they have differently and stick them together. So now we do the same thing we've been doing. I look at that first fraction and I say, okay, this fraction has the x plus 1 in the denominator. What is it missing? The x minus 1. What you do to the bottom, you do to the top. Good. Yep.
Wait, so how is this affecting every other denominator? Why are the factor denominators the new ones that replace the other ones?
It's not that it replaces it. You're looking at all 3 fractions independently and saying, okay, I have one fraction that has x plus 1 as the denominator, one that's x minus 1, and then one that has a combination of the both. So with all 3 of them, what would our least common denominator would be? And it's going to be this one because it has each piece together. Look at the second fraction. It has the x minus 1. What's it missing? In order for it to look like this, what is it missing? It has the x minus 1. What is it missing? The x plus 1. Perfect. X plus 1. So I'm going to multiply the top by x plus 1. Look at the third fraction. In order for the denominator to look like this, do I have to multiply it by anything? No, it already has it. So now, if you look, each fraction, since we've multiplied by something, each fraction now has the exact same denominator. So I have 2 times x minus 1 plus 2 times x plus 1 plus what? Just 1. So we have x plus 1, x minus 1. And we're going to distribute. So 2x minus 2 plus 2x plus 2 plus 1. Sure. Now what? What can we combine? Okay, the negative 2 and the positive 2 cancel. I agree. Now what? Can I add 2x and 2x? Okay, so 4x plus 1 over x plus 1, x minus 1. Is there anything I can take out? Anything that I can factor out? Anything that's exactly the same at the top and bottom? Nope, so that's it. All right, I'm going to write this one down. I want you guys to work on it, and then I'll work it out. Give me 1 second. We'll call this our bonus, number 12. What's going to be my common denominator for this problem? X squared. Good, Luna. Did I say Luna? Good job, Yara. Sorry. And x plus 2. Okay, look. The first fraction has an x and an x plus 2. The second one has the x squared. The last one has the x squared, the x plus 2. So you figure out what would be the conglomeration of all of them. Well, 2 of the 3 have the x plus 2, so I know that's a piece I need. And all 3 of them have at least one x, so I'm going to need an extra x for one of them. So that's how you guys got to kind of look at that. I don't know how. Some of you are going to see it a little easier than others. We just need to practice this a little more. But if I look at this first fraction, and be careful, if you rewrote it, that's fine. But if you rewrote it, it needed to be negative x plus 6. What is my first fraction missing from the denominator? Just one of the x's. Good, Jaden. It's got an x, but I need another one. So if I multiply the bottom here by x, then I have to do what to the top? Multiply by x. What is the second fraction missing? X plus 2. Perfect. So I multiply the top by x plus 2. What about the third fraction? It's not missing anything, so I could just leave it. So I'm going to put the x out in front here just because that's how I like it. So plus x plus 2 times x plus 2 plus 8. Now all this becomes, guys, is a combining like terms polynomial type question. You leave that denominator, x squared and x plus 2. Now we distribute. What's x times 6? 6x. What's x times negative x? Negative x squared. So plus, now we FOIL. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. And then I have plus 8. This is where we've got to be real careful with signs. So I have x squared and then x plus 2. And then in my numerator, start with the highest exponent of x squared. So I have a positive x squared and a negative x squared. What happens? They cancel. Perfect. So I have positive 6x, positive 2x, positive 2x. 6 plus 2 plus 2. Okay. 10x. And then what's 4 plus 8? 12. And if I'm going to simplify this a little bit, what would it become? Right? The GCF in the numerator would be 2. So same thing. So tonight, you guys don't technically have homework. You have practice on this, but it's not due until Thursday. Then tomorrow's is not going to be until Friday. But if I were you, I would go ahead. You have a few minutes, like 15 minutes. I'm going to give you back your quizzes here in a second. But go ahead and start working on it.